In this video, we are going to be discussing describing quantitative data with numbers. So our learning target for the day is I can calculate and interpret measures of center, meaning mean and median. So there's two measures of center for quantitative data. In the previous section, when we're dealing with graphical things, usually it's easier to find median. But today we are going to introduce this idea of mean, which you've probably even heard of more often than median. All right, so let's review how to find the median. When you have an odd amount of data, the median is literally that center value, okay? For even amounts, it's going to be between those center values. So in this case, that would be 18. Okay, so just a quick summary of what you already know. But now let's talk about the new material with this, all right? So to find the mean. To find the mean, we use x bar to represent it. It's the sum of all the observations divided by the number of observations that there were. Okay? So this can take on many forms. It can take on looking like this, like that, or it could even look like that. But the idea is always the same. Okay? So let's find the mean of that first data set. So I'm going to add up all those values. So 13 plus 16 plus 17 plus 33 plus 35 plus 40 plus 52. So they add up to 206, and there were 1, 2, 3, 4, 5, 6, 7 of them. So I'm going to divide by 7. My mean is about 29.4. And what about my other one? So again, to find the mean, simply add them up. So 9 plus 15, let's start over. 9 plus 15 plus 16 plus 20 plus 29 plus 33. So they add up to 122, and then there's 6 points. So then I'm going to divide by 6 to get about 20.3. To be precise, 20.3 repeating. Okay, and again, mean is something I know you guys have done a lot, so I'm pretty confident that you are comfortable with that skill set of finding mean, okay? However, for AP Stats, we're all about efficiency, okay? I don't want you scrambling by hand to do all of these things, okay? So, again, let's talk about how can we do this on the calculator, okay? Because again, the AP Stats test is timed. We are all about efficiency. How can we get the calculator to do as much work as possible for us? That's our goal. So, on the calculator, what we're going to do, again, one of the biggest things when we have data sets is we need to input it into a list, all right? So I'm going to go into the calculator, go into stat, just like last time, edit, and I'm going to put all of those values into a list again, okay? So take those sandwiches from McDonald's and then put all of those values into lists, or not lists, into list one, I should say. Again, you can pause the video to give yourself a chance to do that. I have it pre-done, so you don't have to sit here and watch me go through and do it. So use a calculator to find the mean and median of this distribution. All right, so to do that, we're going to go back into stat. But this time we're not editing a list. We already have the list. This time I'm doing a calculation. Okay, I want to calculate the mean, calculate the median. So this time in that stat option, I'm going to scroll over to calc. Okay, and I'm going to perform a one variable stat. All right, now here, my information is in list one. Frequency list, don't worry about yet. We're going to get to that later. And so I'm just going to calculate this. All right. So some things I want you to notice. X bar, so right here, that is my mean. Okay, so in the one variable statistic, it calculated the mean for me. Okay. And what else? Well, let's scroll down and see. Oh, and it also got the median for me. Okay. So, again, very useful to know how to do this on the calculator when you're dealing with bigger data sets. So you're not sitting there number crunching. It'll do it all for you in that one variable stat command. Okay? So now, so I'm just going to write down. So the median or mean is 26.3. Median is 26. We're going to need that, so we need to make sure we have that written down. All right, what if the fat content of the double quarter pounder with cheese had been miscalculated? It was actually 15 grams more. So what if it was actually 57 grams of fat? How would that change the mean and median? Well, let's look, okay? So the double quarter pounder with cheese was 42. And we're saying, what if it was actually supposed to be 56 grams? So for this what if scenario, I'm actually going to go in and I'm going to play with my data. So I'm actually going to change this in my list to 57. Because now I can recalculate that one variable stat and I can physically see how it changed it. So I'm going to reperform that one variable stat and I'm going to see. Notice the median went up. When contributing more, when adding to the data values, that is directly going to increase the mean. What about the median? I notice the median did not change because remember, the median is based on position. So we had a value that was already greater than the mean and we just made it bigger. So it didn't change the position of my middle value at all because the value I was looking at was already greater than it and I just made it even bigger. So it didn't change what my center value was. So that's the interesting thing that you want to note about outliers and changing values. Whenever you change values, it's going to change the mean. However, shifting an outlier out to be farther away or closer, it's not going to change the median at all. Medians are resistant to outliers, while the mean is not. So let's take a look at what that looks like. Let's expand on that idea. Okay, so the big idea here is outliers do affect the mean, but not the median. So what that means is the tail of distribution is going to pull on the mean, but it's not really going to pull very hard on the median. Okay, so if I want to make comparisons here, so here, look, I see that I have a tail kind of like that. So here, the tail is going to be pulling on the mean, but not as much on the median. So for that battery life example, the median is going to be smaller than the mean. Okay. Turnovers, that looks pretty roughly symmetric. Okay. So what that's going to tell me is the median is going to be about the same as the mean for something that's symmetric. Here I see a tail and it's getting bigger over there. So this time the mean is being pulled by the tail, median not so much. So this time the mean is going to be smaller than the median. Okay. So again, just keeping all of those things in mind, okay? Have those mental pictures of the tail pulling on the mean, but not really pulling on the median, okay? All right, now let's do a little investigation, all right? So I have two sections of AP statistics, all right? So my first section averages 95% on the quiz. My second section averages about 90% on the quiz. Okay, now does this mean that my average is 92.5 for all my students? Well, just like how we weight your grades and for tests versus homework, this is a weighted grade or is a weighted situation. Okay, so let's think about what happens here. So what would the average of my classes be if my first section had 20 kids and the second had 15 kids? So let's take a look at weighting those averages, okay? So in my first class, I have 15 kids who scored 95, and I have 20 kids who scored 90. Then all together, I had 35 kids, okay? So I'm going to type that in the calculator. It's only 92.1%. Again, it's not halfway in the middle. Why is that? Well, because my first section, or sorry, my second section had more kids in it. So it's more heavily weighting towards my average than the first section is. So notice when the groups aren't the same, it's going to be manipulating the mean differently. What if my first section had 30 now? So 30 kids that got 95%. And 10 kids that got 90, this time out of 40. So 30 times 0.95 plus 10 times 0.9 divided by 40. This time, notice that my entire class average is greater than the 92.5 that you might expect, because this time my first hour, which got the better score, was weighted more heavily. There were more of them contributing to my average. And then obviously the reverse of that, you kind of saw this in the first one already, is what about this scenario? Well, again, let's anticipate. This time I have more kids who scored 90 than 95. So it should be pulling closer to the 90 than it is to the 95 because there were more kids that scored that. So this time, my entire average would be 90.7%. Okay, so be aware of all those little details about means. Okay, if the groups aren't the same, you're comparing things, notice it's going to be kind of a weighted mean, a weighted average, depending on how many were in each group. All right, so awesome. Thank you for joining me for this, and I look forward to seeing you in class.